All right, so we're going to begin the 6.4 distribution of natural energy resources. And so we're going to talk about, the first step in distributing our global energy resources is talking about where these energy resources occur. And so basically, where they occur, the distribution is not uniform. So we're not going to find, oil uniformly available throughout the world. All right. So, what that means is that they're unequally distributed. And so, certain areas will have larger pockets of some of these resources than others. And this is what can create conflict because, these resources equal money. And when we're involving money, there tends to be conflicts between countries. And it also can sometimes come down to like a tragedy of the commons sort of thing. And so that can be an issue as well. But the distribution largely depends on the region's geologic history, especially when we're talking about fossil fuels, because the geologic history is what determines whether or not we even have the resource available. And so an example of this would be the Middle East would be the first example I think of pretty readily, because that is a large supplier of the world's, especially the United States, oil. And so the Middle East used to be a large, shallow sea, and that's like the ideal conditions for creating oil. And then, having that impermeable layer of rock that's above the sedimentary rock that the oil is found within, that's also going to, create those ideal conditions. And then another example that I often think about, and I'll get rid of my camera here, is coal in North America. Parts of North America used to be a swampy forest. And so that is the ideal conditions to generate, the peat that that forms the anthracite, or I'm sorry, the peat that forms the lignite, which then forms the bituminous coal. And then eventually over even more time and more pressure, we get that anthracite coal. And so you can see in green here in the United States, up here in Alaska, and throughout North America where we find the lignite coal. And then in orange, you'll see where we find the anthracite and bituminous coal, which is the most common coal used for our energy production. Okay, so let's move on here to the next slide. When we're talking about that geologic history and where we find the resources, we should also talk about, how much of the resource we have left. So in for coal, we do have approximately 100 to 150 years. However, some of that coal is going to be difficult to extract. I'm not sure it's in it, and also we're creating, this world climate change issue. And I showed you a chart earlier that, coal is one of the worst things to use. So I'm not sure we're going to be reliant on coal for the next 100 to 150 years, but it's in the U.S. is one of the has the largest reserves of coal, with Russia behind us, and then China, and then Australia. Natural gas, it's estimated that we have approximately 50 to 60 years left of natural gas. And that includes fracking technologies. So, still, fracking is not a long term solution for our energy issues. And so, where do we have most of the energy reserves for natural gas? Russia, which is why Russia is so, like the rest of Europe, is so dependent on Russia. Iran, Qatar, US, follows those countries, surprisingly, and then Saudi Arabia. So you can see natural gas is found where there's petroleum. So that large petroleum reserves in the Middle East, we can kind of see that there's also natural gas there as well. And then oil, we have approximately 50 years left on our supplies of oil. We have longer with natural gas because of fracking. But with oil, we have most of it, surprisingly. We probably don't hear Venezuela too much when we think of oil. We tend to think of the Middle East first. but then it is immediately followed by Saudi Arabia, which is expected, Iran, Canada, and then Iraq. So those are our supplies, our reserves for each of those different types of fossil fuels. Okay, so let's talk a little bit about fracking. I'm going to talk more about fracking when we do the fossil fuel notes, but fracking that's the nickname of the process. The actual process is called hydraulic fracturing, which really describes more of what actually is happening. We're using water or a liquid to fracture rock. And then from the rock, when we fracture the rock, it releases the methane, which is natural gas. And that has extended our access to natural gas. So we're able to more readily get natural gas out of the rock layers. But it's also extended our availability of it as well. So which then can extend our consumption and on and on. That all impacts the other. So gas is actually trapped in that semi-permeable sedimentary rock layer like shale. And then shale, you can almost even break shale sometimes with your fingers because it fractures very easily, it breaks very easily. Or you can take a hammer and just quickly like tap on it and it breaks the shale. But basically, you can use extremely high pressurized liquids to punch, or, to apply that to the rock layers and then crack the rock layer. And then that releases that methane gas. So fracking from that shale rock, like we said, extends not just it extends, but increases our supply, which can increase our consumption. And then shale gas reserves are considered a fossil fuel, so they're non-renewable. They will eventually be depleted. There is short-term economic profit that still drives the extraction and use of that resource because, a resource is equal money. Money is going to mean we are going to go after it. And so it's been discovered, but there's these unharvested reserves that represent that economic benefit to countries. And so we see countries like China now have the most amount of shale reserves available, followed by the US, Argentina, Mexico, and then on down the line. Okay. Okay, tar and oil sands are another um, fossil fuel that we don't necessarily hear as much about, but they're actually bitumen deposits where crude oil can be recovered. So Canada is the world's largest, has the world's largest oil sands reserves, and just like fracking, it extends that world supply of crude oil. Here's kind of what a tar sand mine pit looks like, so you can see how destructive it is to the ecosystem. And you can also see how much they've started producing per day in the growth that they've experienced in this industry. And so here's our practice FRQ for 6.4. Identify a region of the United States that is likely based on this map. So use this map. So identify a region that is likely to be a large producer of natural gas and describe the geologic features that are associated with those natural gas reserves. Now, don't forget, you can find the answers for practice FRQs on OneNote. And if you have any questions, make sure you're talking to me in class, and I'll see you next time for the 6.5 notes, which are going to be on fossil fuels. Those are going to be long notes, so I'll just warn you now. But you do need to know the information. So I am going to be talking quite a bit about fossil fuels. Okay, all right, I'll see you guys next time.